Assume there are 5 houses and 5 people. In how many ways can person I not go to house I? You see, we have 5 houses and 5 people. Person I cannot go to house I. What does it mean? Let me tell you. We have 5 people, 1, 2, 3, 4, 5 and 5 houses like this. H1, H2, H3, H4 and H5. But the condition given is that 1 cannot go to H1, 2 cannot go to H2, 3 cannot go to H3 and so on. So, person I cannot go to HI. A possible enumeration would be something like this. 1 going to H4, 2 going to H1, 3 going to H5, 4 going to H3 and 5 going to H2. This is possible. Now, let us see in how many ways these people cannot go to their respective houses. So, what do we have to find out here? We have to find out, basically first let us find out what are the conditions, right? CIs that is. Let me write condition 1 as 1 going to his house H1 or condition 2 being 2 going to H2 and 3 would be 3 going to H3. Condition 4 would be 4 going to H4. Condition 5 would be 5 going to H5. So these are the conditions given to us, right? We have formulated them. Now let us proceed further and find out what is N of C1. You see these slots given here? These are the houses. N of C1 would mean those enumerations where 1 goes to house number 1 itself, right? Like this, 1 is in 1. Now, we are fixing this, which means 1 goes to 1 and rest of them can permute in all possible ways. So, in how many ways can 4 people do it? 1 is fixed, so we cannot consider 1. So, out of 5, 4 can be enumerated. One such way is this, right? 4, 2, 5, 3. So, this can be done in 4 factorial ways. Do you see that? 1 is fixed and hence we consider 4 people and hence the 4 factorial. Now, for N of C2, again it is 4 factorial. Why? Because now 2 is fixed. Other than 2, all the others 1, 3, 4 and 5 can be enumerated in all possible permutations, right? Now for N of C3 again it is 4 factorial. Why? 3 will go to house 3, it is fixed and the other 4 of them can be permuted in all possible ways. Now N of C4 again has the same analogous reason as 4 is fixed and the remaining 4 can be permuted in 4 factorial ways, same for C5 as well. So condition number of elements in condition 5 following condition 5 is 4 factorial. Why? Because 5 goes to house 5 itself and the rest of them can go in 4 factorial ways to the other houses. 5 is fixed here. So now we have found out what is N of C1, N of C2, N of C3 and N of C4, C5, right? Now the next step is fixing 2 conditions. N of C1, C2, what will this be? You can see that it is 3 factorial. How? Well, you must not be really stuck here because earlier you saw that one person goes to his own house. Now 2 people are going. So how many remain? 3 people. And they can be permuted in 3 factorial ways. This holds true for C1, C2, where 1 goes to house 1 and 2 goes to house 2. But don't you think it is the same for others as well? What do I mean by that? N of Ci, Cj is 3 factorial for all ij between 1 to 5. In general, this is true. Now, what if 3 people go to their respective houses? What do I mean by that? N of C1, C2, C3 go to house 1, 2, 3 respectively. For the remaining 2 people, 4 and 5, how many permutations are possible? 2 permutations, which means N of C1, C2, C3 is 2 factorial. Can this be true in general? Yes, which means N of Ci, Cj, Ck is 2 factorial for I, j, k lying between 1 to 5. Now, we have 5 people in all and we have covered for 3 conditions. N of C1, C2, C3, C4. You see here what is happening? 1 goes to house 1, 2 goes to house 2, 3 goes to house 3, 4 goes to house 4. The remaining person 5 has only possibility to go to house 5. So this is 1, which means it can be done only in one way. Well, this is true in general. So for all other cases, it is true as well. It is 1. That is 1 permutation for Ci, Cj, Ck, Cl. What would N of C1, C2, C3, C4, C5 mean? The number of permutations where every person goes to their own house. This is obviously 1, right? So N of Ci, Cj, Ck, Cl, Cm is 1 for all of them between 1 to 5. Now, the question is, what is N bar? Which is N of C1 bar, C2 bar, C3 bar, C4 bar and C5 bar. It is N, all possible permutations, minus summation N of Ci, where I is from 1 to 5, plus summation N of Ci, Cj, again Ij between 1 to 5, plus minus summation N of Ci, Cj, Ck, plus N of Ci, Cj, Ck, Cl, minus N of Ci, Cj, Ck, Cl, Cm. So, this is the formula to find out that how many ways can I not go to Hi, right? So, N here is what? It is all possible permutations. So, N bar happens to be all possible permutations is 5 factorial. 5 factorial minus 5 choose 1 into 4 factorial. Why did I write 5 choose 1? Because 4 factorial is true for all the 5 of them, right? Instead of writing 5, I have written 5 choose 1, which is 5 itself. You can also see it as 1 person out of the 5 people, right? Choosing 1 out of the 5. Plus 5 choose 2 into 3 factorial. This is for C1, C2, rather Ci, Cj, minus 5 choose 3 into 2 factorial. This is for 3 people, plus 5 choose 4 into 1 factorial, minus 5 choose 5 into 0 factorial. Now, this can be written as 5 factorial minus, if I expand each one of them, I can write it like this. 5 factorial by 1 factorial into 4 factorial into 4 factorial plus 5 factorial by 2 factorial into 3 factorial into 3 factorial minus 5 factorial by 3 factorial into 2 factorial into 2 factorial plus 5 factorial by 4 factorial into 4 into 1 factorial into 1 factorial and so on. Well, you are expected to write all of this yourself by now. Now, I take out 5 factorial common here and cancel out the common terms. What do I get? 5 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. Do you see this? It's something very familiar to us. Well, this is the answer for the question that person I cannot go to house I. He cannot go to house I in these many ways.